Hello, am I audible? Am I audible? Can someone confirm if I'm audible?
Yeah, you are audible.
Welcome everybody to today's technical session, and will be taken by Abhinav Sarkar. Um, yeah, over to you, Abhinav.
अब क्या आ रहा है? Audible? हम्म, बहुत अच्छा। थोड़ा Is this better? Hmm? Okay. I hope this is better, right? Yeah. Fine. Okay, so good morning, everyone. My name is Abhinav, and I am a senior project technical assistant at e-Yantra IIT Bombay. I will be taking this session on introduction to OpenCV and computer vision. So, first of all, let us just know what this session is going to be about. Since this is a 2-hour session, we'll be getting acquainted with some of the basic image processing concepts. You will know how to use the image processing library using CV library Python. Can someone turn off their sound on the background? It's disturbing. Uh, and I will demonstrate a few applications about image processing in OpenCV. What this session is not about. Okay. So we will not be going into the mathematics behind the image processing and computer vision algorithms. The mathematics behind these algorithms is very complex, and we don't have sufficient time on our hands to actually tackle that in this session. We will not be going into applications based on machine learning or deep learning. This is just basic open CV and image processing. So what are the prerequisites for this session? A little bit of familiarity with Python syntax and the NumPy library. I hope if you are not familiar with the NumPy library, then you will get familiar by the end of this session. The other thing is software installation of all the required software for the session. So I don't know if so there is an installation document which I can share in as a link in the chat if you want to follow along. And you need a little bit of maths to actually understand what is what in this. So what is going to be the agenda for this session? Let's see. So we'll first see what exactly is image processing and computer vision. Then we'll get started with OpenCV using Python. And then we will see two demos, that is object detection and building a document scanner. So first of all, let's just get familiar with image processing. Before we learn image processing, we need to know what is an image. Okay. So for example, let's take the human eye for example. The human eye takes in light from the external, and there is a kind of a lens which is called a pupil. Okay, and what happens is that the external image, the light is projected at the back of our eye, which is basically the retina. And this light or these information, external information, which is projected at the back of our retina, that is received by the nerves or at the back of the retina or the photoreceptors. There are multiple cells there, and that image is translated into something that our brain can understand. And uh, the light. So there is a Hello. So am I audible now? Okay, fine. So let's continue. So the camera basically it consists of one lens and one screen on which the image gets projected. So in the older days, the screen used to be something like a silver nitrate sheet in which when it gets exposed to light, the imprint of an image gets translated into the film. These days we have digital cameras. So digital cameras do something else. So when they capture the external image using a lens that is to how similar to how older cameras used to do, but they also process that to convert that into digital data. Okay, so how is that converted to digital data? Ba- Basically, the digital data is basically there are some algorithms which are applied by the cameras, which intensity values into some kind of actual some kind of values which can be read by a computer. So in the end, what happens to an image is this ma- this matrix of numbers. Basically, what happens is that, so a lot of you might have learned about matrices in school, and you might have thought about where exactly am I going to use this. So this is actually one of the main applications of matrices, that is image processing. Any image is represented as a matrix. So here we have a basic grayscale image. Okay. So what exactly is a grayscale image? Basically, that all the
इधर ना कितना
basically basic basically uh, all the values are given in the form of grayscale. So here what we see is that there are the values range from 0 to 255. Why is it from? Can someone please shut down their audio at the back? Okay, fine. So what we do is that we create a grayscale spectrum. One side is pure black, one side is pure white. Okay, and we assign 0 to black. Pure black is 0, and pure white is 5. That means that any value of gray can be assigned something between 0 and 255. So here we can see that in this grayscale spectrum, there is some value which is 170. 170 is a bit uh, lighter shade of gray. Then 238 is almost white. Then you'll see a couple of zeros in the middle, which means that it is pure black. There is 17. Then there is 17. 17 means that it is almost black, almost black. So these numbers correspond to some kind of these numbers correspond to the color to the shade of gray. So what exactly are these numbers? These numbers are basically called pixels in an image. So an image consists of a number. Okay, the smallest unit is called a pixel. So, for example, if I have an n image, n row, have it can be represented in 8-bit code and binary. Okay, so 255 is, what would 255 be? 1111 1111. Okay. There are also RGB images. So this we were talking about grayscale images right now. RGB images are three different channels. These three different channels are basically the three different channels are basically the three represent R, G, and B. Okay, so this is basically in a grayscale image we were denoting in shades of gray. Okay, so 0 used to be pure, 0 used to be pure, 5 used to be pure white. The shade ranges black to pure red or pure green or pure blue. Okay, in the pure middle will value and the channel the value is 128. That means that it would be somewhere between black and red, so brownish kind of a print. So a RGB image is channels that create gives me a three-dimensional matrix. And in the process, now here's one small just a second. So is this better? I just switched my network. I just switched my network. Is this better? Okay. Okay, so let's move on. Yeah, so did anyone figure out this problem? I'm not sure if the answer was shown to people. So do you guys want me to go back a few slides? Okay, fine. So I think I'll go back a couple of slides then. Okay, so we'll just start with what is exactly an image. Okay, so in a very basic nutshell, an image is nothing but a matrix. Okay, matrix is what is a matrix? Is a set of numbers in a two-dimensional or a three-dimensional or a multi-dimensional space. Correct? So an image is basically a matrix which is usually a 2D or a 3D matrix. Why a 3D matrix? We'll come to that later. So matrix is what? So let's say we have a grayscale. There is a there is a grayscale spectrum which goes from pure black to pure white. Okay, and we divide this spectrum into 255 values. Pure black is represented by 0 and pure white is represented by 255. Okay, and all the values are in between are represented by all values represent different shades of gray. Okay, so for example, at this image, this is a portion of image. All of these values represent different. All of these numbers represent different shades of gray. See, 170 is a lighter shade of gray.
Hello. Hello, sir.
Is the problem occurring again? I'm not sure what exactly is the issue here.
Hello, sir. जरा मोठ्यानं बोला.
Hello, 1, 2, 3, 4.
జియో ఎన్ని కావాలంటే పడిందండి.
Hello, Ranjit.
Hello.
Surya.
Okay. So we are looking into the audio issue.
Hello, ma'am.
Hello, ma'am. You are not on.
Hello everyone, we are sorting the issue with audio. We will start the session soon. Hello, am I audible?
Am I audible? Okay. I hope the sound issue is clear now. Okay. So I hope this is fine. So yeah, should I repeat this section or did people get a basic gist of it? Okay, fine. Yeah, so I'll just repeat it very quickly. So the basic idea here is that just a second, there seems to be some issue. Yeah. Okay. Okay, so let's look at this. So in an image, there are basically the smallest unit of an image is called a pixel. Okay. And a pixel might have a value between 0 to 255. Okay. So for example, if I have an image which is m cross n, that means that there are m into n pixels in that image. Correct? And every pixel will have an inherent value which is stored that might vary between 0 to 255. You might be already knowing that that 0 to 255 can be represented in binary. It takes 1 byte. Okay. So for a grayscale image, what happens is that we represent a grayscale image. 0 represents pure black and 255 represents pure white. Okay, so for a grayscale image, that is a black and white with gray image, there will be this kind of a matrix can be created. Okay, that means that, so for example, there is a 238, that means it's almost white pixel. Okay, there is a 0 here, that is an almost black pixel. Okay, so any image can be represented as a set of these numbers, that is which is basically what is called a matrix. And what is an RGB image? An RGB image is a three-dimensional matrix. So it comprises of m cross n cross 3. That means there are 3 channels, one for R, one for green, one for red, and one for blue. Here also the same funda is followed. That is that 0 represents pure black, but 255 represents the pure red or pure green. So, and any number in between would represent some color which is between these two extremes. And that when you combine these three different channels, then the actual color arises. So, can you just solve this question? What would be the size of a grayscale image with dimensions 32 cross 32 pixels? I'll give you some time to solve this. One KB, 1024 MB, 1024 bytes, 1024 bits. There are a lot of answers here. Okay, so it's a very simple calculation. 32 cross 32 is 1024 bytes, or it translates to 1 kilobyte. Okay, so let's move on to the difference between image processing and computer vision. So you might be a little bit confused that what do these two different terms mean? And often these terms are used interchangeably for each other. So computer vision basically consists of all these areas like signal processing, pattern recognition, image processing, mathematics, physics, artificial intelligence. So image processing is just one subset. Computer vision means that a computer is taking an image and extracting information out of that image. Please stop speaking in the back or unmute mute yourself. Harish Prajapati. So computer vision refers to high level understanding of images, detecting faces, object tracking, etc. Image processing refers to low level processing, such as what happens like if I need to detect some shape in an image, or if I need to remove noise, or if I need to detect the edges in an image, or some corners in an image. Okay, so these are so computer vision would refer to high level tasks like you would say that I want to detect the number of cars that are passing in a video. Let's say 10 in a video consisting of 10 hours of footage. Okay, so that would consist of a lot of high level logic, high level algorithmic logic. Image processing would refer to low level processing that is required to realize that logic. So now let's get down to the programming part. Okay. So we will start with some basic image processing operations. So firstly, we will look into these image processing functions, which is loading, displaying, and saving images. Like when I want to load some image, then then this is the function that I want to use. CV2 IMRead. If I want to display an image, then this is the function that I will use. If I want to save an image to my hard drive, then this is the function I want to use. Okay, right. Let's move to the programming part. The screen is visible to everyone, right? Okay, fine. Is the writing visible? Like, is the font too small? Should I enlarge it? Okay. I think this should be enough, hopefully. Okay, fine. Okay, so we'll look at all these different image processing functions one by one. Okay, so let's look at the basic operations. So first of all, whenever we are writing any Python code, the number one thing that we do is import the necessary libraries. Here, what we are basically doing is we are importing two libraries, NumPy and CV2. Okay, CV2 is the OpenCV Python library. Okay, after that, what happens? Let's try loading an image. What does loading an image means? That we'll load that image into memory. So this is what an image might look like. Okay, so here I have printed two pieces of information. You look at this, that I am saving that image, saving that the image that I'm loading into a variable called image. And first I'm printing the type of that image. Okay, so the type of the image is a NumPy array. Okay, this is a basic class definition or a structure in for NumPy. The second is that I'm printing the information that is inside this NumPy array. So you will see that this is nothing but a set of uh, numbers. Okay. So there's a whole lot of 255s here. That means that it's a whole lot of white in here. Okay. Now let's try showing that this image. So this actually did not work well, because I had the CV2 weight. The CV2 weight key was given the value. Just- Is this visible? Is this second small screen visible to everyone? Oh, I think that it's just showing my window. Let let me hmm. Yeah, I think this small window should be visible now, right? Yeah. So what is happening in this? First, I'm using a function called cv2.imshow. What this function is doing is it's displaying my image. So the image variable that I created earlier, which is used to load that image, that is being displayed. And what does this mean? This string image mean? This is the name of the window. So I can name it anything else as well. Now the second line, CV2 wait key 0. 0 means that this will wait indefinitely until I press any key. Okay. Let's say that I add some number. So let's say if the number here is 2000. Okay. So that means that this window will get opened for 2000 milliseconds and then it will close on its own. Finally, CV2 destroy all windows. That is that it completely destroy the windows. Okay. Now move on. Let's try to check the dimensions of this image. So as I told you that an image might be M cross N or something, correct? So what does that M cross N mean exactly? So here the dimensions is 243, 207, 3. So the width would be 243. The height would be 243. The width would be 207. And what does this 3 mean? Can anybody guess here? Yes. So 3 is so many of you got the answer. 3 means the number of channels. So can this be any other number here? Can this be 4 or 5 or something? Will this be so what will happen if it's a grayscale image? What should be the image dimensions? Let's see. So to load an image in grayscale opens the imread function. You just need to add an extra parameter, that is 0. So what we did here was that we gave the path of that image and we added an extra parameter called that is 0. Okay, so let's check the dimensions of this. You'll see that this is a 2D image. Since there are not 3 different channels here, there is only two dimensions. Okay. So remember this shape function can be used to find the dimensions of any matrix. Now how do we save an image? I'm going to skip saving an image because because we are running a bit short on time and it's kind of trivial. So let's go to accessing the individual pixels. Okay. So for example, let's look at this pixel gray, pixel RGB. Okay. What does this line mean? Image gray 120, 120. What does this mean? Can somebody write in the chat? Yes. So a couple of people said this correctly. This is the row and column. So what happens here is that I have stored my gray image in this variable called image gray. So image gray consists a matrix which is 243, 207. Okay. So what I'm doing is I am accessing the 120 cross 120 pixel. Okay. And in RGB, what happens here? Why? What does this particular symbol mean? This symbol basically means that I want all the the values of all the three channels. So 120. So for the image, for the actual image at 120 comma 120, there will not be one pixel, there will be 3 pixels. Correct. There will be R pixel, there will be a green pixel and a red pixel. Correct. Okay, so 3 values will be there and I want all 3 of them. I could easily write 0 to 2 as well. That might also work. So let's try running this. So here the pixel color for this is 29. This is for the grayscale image. And for the RGB image, the pixel color is 255, 1, 1. We can also try to modify these pixels. So you'll see that what I have done here is I have actually set this particular pixel that I have to 255, 255, 255. Okay. And you'll see that there is one small, very small, I am not sure if this is visible to you, but there is a very small dot uh, in the center of this image. That is a white dot, which I created by modifying that particular pixel. So let's move on. So let's try to access a region of interest. Let's say that I don't want to access just one single pixel. I want to access a set of pixels. Okay. I want to access a whole area. So what I can do is I can do this kind of array slicing, which is very common in NumPy arrays. So let's say I want to set the values for 0 to 25, 0 to 25, and all 3 channels. What would be the output of this? Is this visible? So what happened here? I created a small black square at this corner. So from 0 to 0 to 25, 0 to 25, and I set all these pixels to 0, 0, 0. What does 0, 0, 0 mean? That is pure black. Okay. So this can also be used for cropping an image. So let's say that I just want to take one small part of this image. I can just use this slicing method to crop this image. So you'll see that I have I cropped the below portion here by just taking 0 to 255, 0 to 255 and all 3 channels. Now, how can I check these individual channels of this RGB image? So let's say that I want to see what do these individual channels look like actually. So let's see that. So what did I do here exactly? I created three different variables: image P channel, image G channel, and R channel. And in that, I just added the whole image, but only added the separate channel. Okay. So this is 0. 0 is for blue, 1 is for green, and 2 is for red. And then I did a CV2 IM show on all of these. So what do you see here? So for the blue channel, this portion is not visible. Why is this portion not visible? Can somebody say? This portion is not visible because this was pure blue in the original image. So in the blue channel, this will be pure 255. Okay, and these will be uh, for these portions will be pure. uh, These portions will not be visible there. Okay. So similarly here. So for example, the green part is not visible here because the green is represented by 255 here. Value 255, and the rest, the other values are 0 and 0. So red would be 0. That means that this is red. That means that this is 0, and blue will also be 0. That means that this is 0. So we have reached the end of the first part. That is the basic operations that we can do with an image. Now let's move on to the second part, that is how we can resize or rotate an image. Okay, so let's see how to do this. So first of all, we import all the libraries. Now let's see what our image here is. I hope everything was clear up till now in the basic operations part. Okay, so let's look at this here. So as you can see that this is a very big image and this is not fitting into my screen. And what I need to do is that I need to kind of uh, scale it down so that it would fit into my screen. Correct? So so as you can see, the dimensions are too big, 2624, 1920. So this won't fit into a regular screen. So how do I resize this? So first of all, there's a function in OpenCV that is cv2.resize. Okay, what happens here is that let's say that we have the height, comma width, comma dash is image.shape. Why did we add this dash here? Because we don't care about this value. So we did not create a variable to actually store this. So we store the height of the image, we store the width of the image. Okay, now what do? We modify the width of the image to 500 pixels, and we modify the image by specifying the width comma height. Interpolation, this is one setting that you need to add in the CV2 resize. So it needs to be CV2 dot inter underscore linear. So why it needs to be this? that you will find in the CV2 docs. We won't, the OpenCV documentation, we won't go into that for now. So let's see what the output of this is shown. So as you can see that the width has been adjusted, but the height is still very large. It's 2624 pixels. Okay. Now, how do we change the height? The height can be changed by setting the height to some value. So let's say I also set the height to 500 pixels. Now let's try this. Yeah, so people who are asking interpolation, interpolation is basically one setting that you need to add in the cv2.resize function. Okay, this is one parameter which is compulsory here, and you'll so we are not going into detail like what exactly does this interpolation means, because we are a bit short on time. But for now, you can just understand that you need to set when you are using cv2.resize, you can set it to interpolation is equal to cv2.inter_linear. So further information you might find in the OpenCV documentation. Okay. So moving on. So as you can see that we resize this image, but there is a problem here. Like we did not manage to preserve the aspect ratio of this image. Okay. So this image used to be 2624 comma 1920, but we did not preserve the aspect ratio. So this looks very weird. So how do we solve this? We do this by using a bit of maths. Okay, so let's see. So just just go through this code once. What are we doing here? First, in the first line, we are first storing that image, okay, in a variable called image. And we also created a second variable, scale factor, which is how much we want to scale this image. Now, obviously, in our case, we want to scale this image down. Okay, that means that the scale factor should be less than 1. So 0.3, that means we need to scale it to 30% of the actual size. Okay, the second thing is height, width, channels. We set it to image dot shape. Okay, that means that we are setting the height to what the actual image height is, the width to what the actual image width is, and the number of channels to the actual number of channels is. After that, we scale the height and width by multiplying it with the scale factor. So in this case, 2624 gets and 1920 gets multiplied by the specific scale factors here. And we also convert this scale factor might not be a decimal, might come as a decimal number. So we also convert that into an integer, because obviously we are dealing with integers here, whole numbers. Okay. And after that, we put these revamped values into the cv2.resize function. So here you can see that the right now the picture is more clear. The aspect ratio is maintained and I can basically see the whole image. Okay. Okay. So next what we are moving to is rotation of an image. So what does rotation of an image mean? So let's say that I want to let's say I have this particular image with me. And what I want to do is that I want to rotate it along one specific axis. Let's say that I want to rotate it around the center. Okay. So how do I do that? So for that, we have two functions, that is get rotation matrix 2D and var affine. So before we go into these functions, let's try to understand that what does rotation actually mean. What rotation means is that we are trying to convert this matrix. So this is nothing but a matrix, right? A three-dimensional matrix. We are trying to convert this matrix into something else. So let's say I want to rotate this image 45 degree to the left. Okay, that means that this pixel would get shifted somewhere here. Okay, this pixel would get shifted somewhere here. Some other pixel would get shifted somewhere here. Okay, all the pixel values will get shifted to some different place. And how is that achieved exactly? That is achieved by multiplying this to something that is called a rotation matrix. Okay, so the rotation matrix is basically that when you multiply this matrix with the rotation matrix, it will it will move these pixels from their original position to the desired position. So what does this rotation matrix actually do? What does this require? It requires the center of rotation. So the center of rotation needs to be somewhere. So the center of rotation can be here as well. Center of rotation can be here as well. It can be anywhere. Second thing is the angle of rotation, the degrees of rotation. And the third thing is the scale factor. So if I want to scale the image up or down, then maybe I can add the scale factor here as well. And what does this var affine function do? This will actually multiply this image with the rotation matrix and give me the rotated image. So look at this first. So what I wanted to rotate this 45 degrees, and the center of rotation is 150 comma 150. That is the center of this. This is a 300 plus 300 image. So the center of rotation is right in the middle. Okay, I can change this as well. I can say maybe the center of rotation can be 0 comma 0. Sorry, 100 comma 100. So this did get rotated, but some part of that image gets cropped out. Because why did this get cropped out? Because we specified the width and height of the image. The width and height of the image cannot be changed. Maybe we can adjust the width and height of the image according to the size, but here we have chosen the width and height as the same. Okay. There can be many ways, So for example, if I could uh, adjust this width and height, there are many mathematical methods to do this, so that I can adjust this width and height to cover the whole of that image and not crop out parts of it. And also there are methods to actually fill this uh, fill this area with which is black with white, or the background of that image. So all that is beyond the scope of this. So is this clear? Okay. So let's move on to the third portion of the let's move on to the third portion of this, that is drawing functions. Okay, so let's see what exactly are the drawing functions. So as the name suggests, drawing functions are when we want to draw something over the top of an image. So let's say that we want to annotate something on an image, we need to add some text, or we need to do some fun stuff with that image. Okay, so let's see how that would work. So first of all, importing the libraries, that goes without saying. Now move on to the second thing. So first thing we want to do is, let's try to create a blank canvas image. That is the uh, an image which is totally black. Okay. So for that we use a function in the NumPy library, that is np.zeros 500, 500, 3 np.uint8. So can somebody tell me what this first term means? Five hundred, 500, 3. Yeah, so this means that it is a RGB image which is 500 cross 500 in size. Correct. And what does the second parameter mean? uint8. Why use uint8? So this is basically the data type. So this means that every value needs to be between 0 to 255. Okay. And np dot zeros, which means that all the values in this matrix would be initialized to 0, 0, 0. Okay. So let's try running this. So you'll see that this is a blank canvas that we have. Now let's try drawing something upon this. So first let's start with trying to draw a simple line. So the function that we are using is cv2.line. So what does cv2.line actually do? It takes two points, which is the two ends of the line. So in this case, I have specified these ends as 499, 0 and 0, 499. It also takes the color of the line. So the color, so 0, 255, 255 means yellow color. And the thickness, like how many pixels width the line should be. So in this, I have specified 3. So this function basically takes all these parameters and draws the line on top of the canvas. Is that clear? So let's try to draw a rectangle. So again, the the pattern would be very similar. So we have 2 points, which is the top left corner, which are given by the top left corner and the bottom right corner. The top left corner is 200. So here I have, let's say, specified 200, 200, 300, 300. And the color is 0, 255, 0. What would be the color here? Yeah, it would be green. Okay. So why is that this line is still appearing? Can somebody say? So the canvas matrix, I am repeatedly making changes to that same matrix. So anything that is added, it gets added on top of the previous values. So you'll see that this line did not disappear because I changed the actual canvas matrix. Okay, but when I call the cv2.rectangle function, then these pixels got overwritten. So again, circle, very simple. Here we are just selecting one single point and the radius of the and we are selecting the radius, which is the radius in pixels, and we are selecting the color. So what would 255, 255, 0? What color would that be? So let's see that. So we have drawn a circle which is at the center of the canvas. So the center is 250, 250, which is at the center of the canvas. Radius is 70 and color is light blue, which is 255, 255. Okay. So again, this is the syntax is more or less same. Like you just specify the point, the radius, the color, and the thickness. Okay, so let's try to create something interesting here. Let's create a blank canvas from scratch. So what would be the so try to study this portion of the code and try to understand what would be the actual output. What do you think would be the actual output here? Look at the values very carefully that are specified here. So any idea what exactly are we making here? So what does this first portion mean? What is happening here? So this is as very obvious, this is a circle. Okay. What is this second portion? So here you'll see that I'm drawing 3 lines here. But how am I drawing these 3 lines? Look at these coordinates of these 3 lines. So you'll see that these 3 coordinates. So these 3 lines basically draw a triangle, correct? And the final one is a vertical line. Let's see what the output of this is. So we have the circle, we have the triangle, we have the vertical line. Yeah, this is the symbol of the Deathly Hallows. The last part I purposely hid because I did not want to give you a hint about this. So the final, if you want to put any text into an image, then we have this function that is called cv2.putText, and this consists of the basic things. Okay, so for example, you need to specify the font. So OpenCV has some saved fonts. So font Hershey Simplex is one of the saved fonts in OpenCV. Then you need to specify the color. You need to specify the font scale, like big or small. Then the thickness. Then you need to specify the thickness of the line. Okay. So that's, I guess, most of the drawing functions. So let's move on to some of the demos that that I was planning to show you. So we have 2 demos here. That is object detection and document scan. So we are running a bit short on time, so we wasted a bit of time with the network issue and everything as well. So we'll try to make this quick. So everyone understood until up till this point, right? These are the pure basics of OpenCV. Like these are the basic functions that you can just you can learn in one day. Okay. So let's move on then.
वो भी मतलब अगर एक्टिव है तो उनका हर एक का मतलब अगर हर एक को मतलब अगर वो टेक्स्ट फॉर्मेट में है
Okay, so
one repo where all the other internship नहीं एक्चुअली समर इंटर्नशिप का अलग करते थे क्योंकि अभी अपना बस प्राइवेट पर ऑफिशियल वेबसाइट पे तो नहीं हाँ नहीं इसीलिए
okay. So let's move on to the second part, that is object detection. Fine. So what exactly is object detection? So object detection would come in multiple object detection comes in multiple ways. So let's say that I gave an example that if we want to detect cars in an image. Okay, so that would be some level of object detection. So right now, what we are dealing with is the very simplest form of object detection, which is based on color. So what we will be doing is that we will be detecting the color of an object, and based on that, we will try to find the position of that object in that image. Yes, yes. Hello. Yeah. So for color detection, we need to learn about different color spaces. So what we have been doing right now is we are dealing with the RGB color space, correct? So we have a red component. Any color can be specified. Any as a set of three components: red, green, blue. Okay, but this is not the only color space that exists. There are multiple kinds of color spaces that exist. So one other color space is hue, saturation, value, or hue, saturation, luminescence. Okay, so what this color space actually does is that this groups similar colors in a same area. So you will see that most of the blues are uh, grouped here. Okay, most of the greens are grouped here. So the hues are grouped in a, and these are basically denoted in this conical kind of this conical kind of space. Okay. So for object detection, usually we use HSV color space over RGB. Why is that? That is because there are couple of reasons that different shades of a color fall in the same range for HSV, while in the case of RGB that might not be different. So what happens is that for, let's say, when you are capturing an external image from an external noisy source, okay, so that source might not have that source might that source will have lighting effects, lighting condition problem issues. Okay, and that might change the shade of the color which is which is seen by the camera. Okay, and that would basically make our algorithm. So how are we doing object detection here? We are setting a threshold that between these, that if any pixel value falls between these values, then this belongs to our particular object. Okay, so and if does not belong to this particular range, then it does not belong to our particular object. So we use HSV because it's a bit less sensitive to external light. RGB is much more sensitive to external light. So what exactly are we doing here? So for example, we need to isolate this apple in this. Okay. So how do we isolate this apple exactly? Basically, what we want is that we want to filter out all the shades of red. Okay. And we want to leave out all the other colors. So we will set some thresholds that only allow the shades of red to exist. And what we do is we create a mask. A mask is basically that where the image has red color visible, that part is shown as white. The all of the rest is shown as black. But you'll see that this is not always the case. There is always some noise in an image. So let's say that, as I told, external lighting causes disturbances in an image. Okay, so there might be some external noise which might appear as pixels, white pixels in the masked image as well. And for that we use some noise. Uh, just a second. And for that we use some noise reduction methods, which are erosion and dilation. Okay, so what does erosion and dilation mean? Dilation means that it expands the boundary of white areas. So you'll see that if this is some white pixel in a blob of pixels in my image, then if I do a dilation operation here, then that blob will increase. Erosion does the opposite. It will decrease the boundary of white areas. So you can see that there are two blobs of white here, but after an erosion operation, one blob disappears. Okay, so it eliminated some noise into the image. So both of these are used according to different situations. Like there are more noise removal operations as well, but these are the most basic of those. The final thing is contour detection. Contour, what exactly? So once we have created a mask, what we want to do is that we want to detect the boundary of the detected image. So let's say that uh, I have the apple. So I have this apple. Okay, so I want to detect this boundary of this image, and I want to highlight this boundary as it has been highlighted here. Okay, so this is called a this is called a contour. Okay, so contours, as you can as it is written, they are basically closed curves. Okay, so we'll move on to the actual programming part now, and we'll go step by step and try to understand these operations that I discussed one by one. Okay, I'll just stop for a minute. So is my code visible? I think the font is a bit. Is this visible now? I hope this is visible. I increased the font pretty drastically now. Okay. So let's see how video cap. So first of all, we will see how video capture works actually. So I think we should exit Jupyter library first. So just give me a minute. Okay, fine. Okay. So just so for now, just ignore the code which is commented here, and I'll explain all this code one by one. First, let's try to run this code first. So this frame should be visible to everyone, right? Yeah, so what exactly am I doing here? I am basically capturing the video feed from a webcam. So how am I doing that? First of all, let's go to the code as always, import numpy, import cv2. Okay. Now what the first thing that I do is that I create a video capture object. So this is basically when I want to attach a camera. I want OpenCV to actually identify a webcam that is connected to my system. Okay. Okay. Create a object. And what does zero mean? Zero means that it is the first camera. It is the first. There might be multiple cameras uh, attached to a laptop or a computer. Okay. So for example, in my case, I don't have a primary. I don't have a webcam, inbuilt webcam in my laptop, so I'm using an external webcam. Okay. but some of you might have an inbuilt webcam in which 0 would mean the inbuilt webcam and 1, 2, 3 might mean some external webcam which you might connect to your. So this kind of numbering needs to be specified here. Okay. So what does while or true mean? Can anybody say? Infinite loop. It's very simple. So I want to run an infinite loop, and at every time that loop starts, I want to capture the frame from the camera object. Okay. And if I go to the bottom, what is happening? I am using cv2.im to show that frame. So that frame keeps getting updated. So that means that I'm showing a live feed of my video. What would this line mean? Can somebody say? So wait key function, I am pretty sure you might you might have understood. You might know, right? What does wait key mean? That when I am using CV2 IM show, I need to use CV2 wait key to specify how much or how much time that frame would appear on the screen. So one means that that particular window will appear for 1 millisecond. Okay. Where exactly is the delay? Is it again an audio issue? Okay, okay. So wait. Okay. So I don't think. I'm not sure why the screen is appearing blur. Okay, so are you guys able to see the text easily, or is the even the text a bit blurred? Now, is it fine? Okay, maybe there might be some computation issues or something. So going back to this, so what is the gist of this? So what I'm doing is that I'm creating a video capture object, which is basically that I'm specifying that I want to capture the video from this webcam. Then I'm capturing each frame and storing it into a variable called frame. And after that, we at the end of this at the end I am displaying this resultant frame. Okay, and wait key 1 means that this frame gets shown for 1 second and then it gets deleted and it gets refreshed with the another frame. So if I press Q, then this window gets closed and this breaks out of the whole while loop and ends the program. Okay. So this is just for showing the basic video. Okay. Now let's see how now let's go step by step for the object detection. So someone is asking why is odd is Q. So basically what odd Q means is that when I press the button Q on my keyboard, only then this will break out of the loop. It will not break out if it is any other key. Is that understood? You can use any other key as well. Okay. So this is this was just show step by step showing each of these so this was just for showing the video. Now let's go step by step for object detection. First, what we need to do is we need to convert the frame to HSV. So what we are doing is we are creating two frames here. We are creating two more images here, an HSV image and a grayscale image. Okay. So for HSV image, we so for both of these we use the function cvt.color and we use these parameters color underscore bgr to HSV, color underscore bgr to gray. What does and what would be the output of this? Now I know every time I run this the screen tends to get blurred, so I'll try to. So what I'm doing is that I'm showing the showing all these three frames here. Let's try this once. So is this visible? It might get a bit blurred or laggy, but this is visible, right? So what? So this is my original frame. This is my grayscale frame, and this is my HSV frame. So what I want to do is that I want to capture this orange part, orange face of this Rubik's cube. This is the object that I want to detect, this orange face. And what I want is I want to specify the colors of this particular, like I want to set the thresholds that so that this gets isolated, these colors. Okay, so let's see. So we'll open one another we'll open one another piece of code here. Is this visible? Okay. Okay. So what we want to do here is we want to try to isolate the threshold so that only this orange section is visible. Okay. So how do we do that? Let's try to reduce this a bit. Let's try to increase this a bit. Okay. So here you can see that for values here, so let's say for Q value, which is 0 to 40, approximately 40, for saturation value, which is between 85 to 255, for the third value component, it should be 175 to 255. So for all that, we have kind of perfectly isolated uh, this orange color in this image. Okay, is that clear? Is there anybody who did not understand what exactly we did here? Okay, so what we are trying to find some thresholds in which this particular color lies. Okay, so this is orange color, but obviously all these pixels won't be the same, won't have the same values, correct? They might have different values. So I want to isolate these. I want to isolate this whole thing out of that image. And what I need to do is I need to create some thresholds in order to isolate. So if the pixel values lie between these thresholds, that means that in the mask that would be denoted as white. If it does not lie between these thresholds, that means that it in the mask it will be denoted as black. So you'll see that here, so this gray value does not lie between these selected thresholds, 0 to 41, 85 to 255, 177 to 255. So these gray values don't lie between these thresholds. So in this masked image, this is black. Okay, and if if the values lie between these thresholds, then it is white. Is that understood? Okay, so moving on. So here we have, like, based on that, we have kind of created two variables and given these lower and upper thresholds. So the lower threshold is 0. So so for value 0 to 40, for S value 85 to 255, and for V 176 to 255. Okay. And we create a mask, which is it is checking if these values lie between if any pixel lies between these values, then it will assign that, it will create a separate image and assign that pixel as white, otherwise black. So let's test this out once.
मैंने एक ही एयरफोन है ना कर रहा हूँ मैं क्या
So you'll see that this is that this tends to get visible. It is slightly lighting dependent, so it might, so the ranges can be adjusted a bit, but overall it gets detected pretty well. Let's try to change the values a bit more so that it gets detected better. Let's yeah, so now it's getting it. So it's getting detected slightly better than earlier. Correct? Okay. So let's move on to the next step. So did you guys understand what we did here? What is this function cv2.inRange used for? This is basically used for creating a mask, okay, to isolate the colors that we want. Okay. Now what we do is we are removing some noise in that image. So for that we use this function cv2.erode. That is, we are using an erosion operation. So if there are any stray pixels in that image, that those will get removed. Let's see if that happens. Okay, so this okay. So there is comparatively less noise, but to be honest, पहले भी उतना noise था नहीं. So next, what we want is we want to draw the boundary of this detected area. Okay, and for that we need to find contours. Mhm. Okay, so actually we need to draw the contours as well, but okay. So what exactly does this find contours do? This find contours will basically what it will do is that we are specifying this masked image uh, in this find contours function. Okay, so what this will do is that it will find the boundary of that white area that we have detected, and it will give us a set of set of pixels which depict that boundary. So you'll see that if when I printed this contour, this is a set of numbers. This is nothing but a set of numbers. Correct. What do these numbers denote exactly? These numbers denote the boundary of the white area. The pixels that make the boundary of that white area, basically. And we can try drawing this contour as well so that it gets more clear to you. The detection is still not 100% because maybe because the lighting and the angle. So we have to play around with those values a bit. But overall, you can see that this boundary of this white area is getting depicted here. Is this visible to everyone? Okay. So now what we might want to do is we might want to find so this we might want to find the biggest contour in this. So in any image, there might not be just one contour. There might be many contours, many boundaries. Okay. And usually what you want is the biggest boundary. Okay. So if your image might have a bit of noise, then there might be very smaller contours as well that might appear. So what we do in that case, that we want the biggest boundary, which is our image. So what we want to do in that case is that we want to filter out all the contours based on area and just select the biggest contour. Okay, the biggest boundary basically. So for example, so this is a basic for loop that we used here. We created a empty variable here and we loop through all the contours in the contour in the list of contours, and we see if the area is greater than 200. Okay, this value is a value you can set based on experimentation. 200 is just a very small value. Okay, so this will eliminate all those small noises which might appear as contours. Okay, and we just add the biggest, which is the main boundary, which is the boundary of our detected image. Is that clear? Okay, so what didn't you understand? Okay, the area command. So what the area command is doing is that it's calculate. So so when we use this find contours function, there might be multiple contours that are detected in this image. Okay, the main contour is the object that we have detected. Okay, but there might be smaller noises as well, which we don't want. Correct. And what we want, we don't want these smaller noises to be detected as objects. So what we want is that we can filter based on area. So contour is a closed curve. So it will have some area which it encompasses. So obviously our object will have the largest area, and all these noises will have a very small area. So that is where we use this for loop to kind of filter out those small areas and only preserve the biggest contour, uh, that is our object. Is that clear? Let's try running this once more. So you will see that when I'm showing this image, so you'll see that there might be some smaller. There might be some. There might objects being getting detected as well. I don't want these. So can you see these red dots and all? Or this? Maybe you can see this now. So this is noise. This I don't want this. So what I can do is maybe increase the size of this. So let's try to make it 500. Okay. Yeah, so you can see that right now all these extra noises have been eliminated. Only my orange color is getting detected. That is because I filtered based on area and just selected the one with the largest area. Okay, is that clear? So what if I also want to find out the coordinates of the center? So that can also be done very easily. Let's try that. Okay, so for to find the coordinates of the center, we use a function called cv2.moments. So you'll see that that I'm able to display the coordinates. So basically what I'm doing is that I'm using a function called cv2.moments to find the x and y coordinates. And after that, I'm kind of using the drawing functions that are there. cv2.putText to actually display that coordinates on the image, on top of that image. So let's try to understand this part of this code. Okay. So what exactly is this doing? These three lines, what are these three lines doing exactly? So what it's doing is that it's getting it is getting the main contour that I have, that is the main object boundary of my object that I have detected, and it's trying to find the center of that. Okay. And it uses an algorithm in cv2.moments, and the x and y are given by these two equations. Okay. So I won't go into what these terms exactly means, M10, M01. So I won't go, these are given into the documentation. So you just need to understand that when you want to find the center of any contour, then Cx and Cy need Cx and Cy need to be these two terms. Need to be these two values. Okay. And what do I do next? What does 0 mean in the M command? Where exactly? This, do you mean this 0? Okay, so why is it so why am I just specifying this 0? So ideally speaking, this main contour list, this should have this this is a list. This main contour is a list of values. Okay, but I am just specifying this. I just want the first contour in that list. So this is actually a list. Okay. And I want the first value in that list or the only value in that list. There is no other value. So that is why 0. Okay. So I'm guessing this. So did you guys understand these up till now? Okay. So we are a bit over. We have overshot the time. So we'll cover the final module, that is the document scanner, very quickly, because we don't have a lot of time to discuss that part actually.
Last time.
Just give me a moment. Document scanner, I'm pretty sure you might be familiar with these apps, correct? Cam scanner, Kagas. There are multiple. There are many apps like these in on the App Store these days. I mean, this is what college students use for copying all those assignments and stuff. This is kind of a bread and butter for college students. Okay. So how do these apps actually work? So what? So you will see. You might be familiar with this kind of an interface, that when you capture an image using this kind of this app, this document scanner app, so you get this kind of an interface, correct? What they want you to do is they want to specify the corner points that you want to get cropped. Okay. So let's say that I have this image. I have this image that I want to get cropped. Okay. So I want to drag these. I want to drag these corners to here, this corner to here, this to here, this to here. Correct. So what I'm basically doing is that I'm specifying the 4 anchor points, the 4 corner points of that image. And what happens after that is something called a perspective transform. So what exactly is a perspective transform? A perspective transform is that given that we have an image in which we have the initial 4 corner points and the final 4 corner points, the perspective transform kind of transforms this to get me a bird's eye view. It will transform this image into this based on these 4 anchor points and these 4 anchor points, the initial and the final. How is it done? Again, matrix multiplication. Like everything happens in image processing usually with matrix, usually with some level of matrix multiplication. That we want, if we have this matrix with these values, we want to find some matrix which is called a perspective matrix, a perspective transform matrix, and so that when this is multiplied by this gets transformed into this. Okay, So let's see how the code looks here. So first I'll just give you a basic demo and then I'll walk you through each and every single part of the code. First, let's just see a basic demo. Okay, so this is my image. So, and what I want to do is that I want to kind of isolate this. I want to, I, I scan this particular brochure that I have. Okay. So what I do is I specify the corner points. Once I specify all 4 corner points, I have my final warped image. Okay, so you can see the difference between this and this. You are basically seeing a bird's eye view of this image. Let's try with another image. Okay. So let's try with this image first. So we have the 4 anchor points, and once I select it, it gets warped into this. So you'll see that most document scanners work similarly, correct? So how does this exactly work? Let's look at that once. So first of all, let's look at some of these things which are additional, but not. So there is one function called select points, which is used for selecting these 4 points. So this is basically a mouse event. So when I'm double clicking at any pixel on that image, this gets added into a list called anchor points. Okay, and this list is basically checking if until there are 4 points in that. Okay, so we have created this function called apply perspective transform. So what does this apply perspective transform function do? First of all, let's look at these 2 lines, order points and TLTRB. Okay. Okay. So what exactly is order points doing? So let's say that I am selecting images in any particular order in my image. Okay. So for example, if I run this program again, so I might select this point first, then I might select this point. Okay. Then I might select this point. Then I might select this point. Okay. So these these pixel values are getting stored in the order of of how I am clicking them. But I want them in a very specific order. Okay. I want First, I want the top right, sorry, top left. Then I want the top left pixel. Then I want the top right pixel. Then I want the bottom right pixel. Then I want the bottom left. I'm going clockwise. Top left, top right, bottom left, sorry, bottom right, bottom left. Okay. So so if I have a list of normal points, how do I order them in such a way? So for that, I have created a function called order points. What this function is doing is that it will just a sec. Okay, so so what is happening in this function? First, we are creating a numpy array which contains all my 4 points. Okay. Now rect 0 and rect 2. Okay, these two variables would correspond to top left and bottom right. Okay. So what happens is that I am okay. Okay, so I kind of forgot the exact logic here, but let me. Okay. So here's the thing. So what happens here is that I am adding these 4 points into a numpy array. Okay. So basically I'm taking the sum of all these points along a single axis. Okay. That means that all the vertical points that means that all the x values are getting added and all the y values are getting added. Okay. After that, what happens is that I take the smallest x value would correspond to the top left most it will correspond to the top leftmost pixel. Think about it this way, that if this is my image, okay. So if I want to select the top left corner, okay. So the top left corner would be the smallest sum of all the x's. Okay. And similarly, the bottom right would be the largest, Okay. In a similar way, we also calculate the difference along this axis, and that way we get the bottom left, sorry, bottom left and top right. So ideally, so this basically this function is doing that, it's ordering all these points in a particular order. Top left, top right, bottom right, bottom left, bottom left. Okay. Now, after that, the next step that we need to do here is calculate the width and height of our image. Okay. So basically what we are doing here is calculating the distance between these points. So let's say that width A is calculated by calculating the distance between this and this point. Okay. And width B is calculated by calculating the distance between this and this point. Okay. And the max width, that is the width I want my image to be, that is whichever is the larger of these two widths. Similarly, we calculate the height as well. Like the height A would be the distance between this and this point. Height B would be the distance between this and this point. And the difference between we just take the maximum height. Okay. And this DST is basically giving me the end dimensions of the final perspective image. So 0, 0 to max width minus 1, max width minus 1, 0, max width minus 1, max height minus 1, 0, max height minus 1. So this creates a array which has these four extreme points. These four extreme points of the final perspective image. Okay. So this is basically what we discussed earlier here. This DST is what we discussed here. These four coordinates. This is getting stored in a NumPy array. And this rect is getting stored in another NumPy array. That is the top left, top right, bottom right, bottom left. Okay. And using that, we use the function cv2.get perspective transform. So this gives me the perspective transform matrix, which we want to get, which we want to multiply this to get this. Okay. So finally, the warp perspective function is doing what? It's multiplying your actual image with this perspective transform, and also specifying the max width and max height that you want, and returning that warped image. So finally, when we show that warped image, it gets shown as this. So that was the final demo. Any questions? So we have a small short quiz for you guys. It's just a 10-minute quiz. I'm sharing the link for that quiz.